and welcome back to the channel. This is going to be a big one for the hop guys. In this video, I'm going to show how to do a 12-volt direct power setup for the hop servos. I'm going to be basically pumping 12.6 volts of lightning. Let's get into it.
Warning: this video contains super awesome content not suitable for people who don't enjoy super awesomeness. Viewer discretion advised.
So I guess we'll start off the video with the warning.
Warning.
Everything we're going to be doing in this is basically in order to put more voltage than these servos are designed to handle. These are 8.4 volt servos. Right now what I'm running is the Jevries super pump. It's the same for the Reefs 300, the piston pump, or the A81 BHP that's based on. These are all 8.4 volt servos. Their circuitry is really designed to handle a maximum of 9 volts. We're going to be pumping 12.6 volts into these things, which is essentially about a 50% increase. So we're doing 150% power through these servos. That's a significant amount past what these servos are designed to run at. So I mean, at this point, there's no warranty, there's no, is this safe, is it not safe? I mean, for the most part, a lot of us have been doing it, so in that sense, it can be safe. However, you can burn up a servo at any time. And if that happens, it's most probably because we're putting too much voltage through them. So, I mean, is it safe? It's safe until one burns up, is essentially the way it is. So you got to look at it like drag racing or anything that you're competing in. If you're not willing to break your shit in order to win, you're not trying hard enough to win. This is basically the way that we're getting the most power into these servos to get the highest hops, to get all the radical hoppers, the ones that are really competing in the competition. They're all running a direct power setup, running full 3S batteries, right? 12.6 volts. Going forward from here, what I'm showing how to do is to direct power any servo. So essentially you can run the Reefs 300, Jevries super pumps, AGF A81 BHP, or the piston pumps. Any of these servos you can run at 12.6 volts, but doing so, you're doing it at your own risk, so you have to keep that in mind going forward. So with the piston pumps finally being released and people getting some servos in their hands, I do need to talk about it. Now, the piston pump the servo is essentially based off of an A81 BHP, except the difference is that it has been configured to work as a direct power servo only. So the servo itself has 2 plugs. One is only for the signal wire, and the other one is going to be for the direct power supply from the battery. And with that, you cannot actually use the servo as a normal servo. Now, potentially, you can use some connectors to reconfigure the direct power setup to run off of a regular Futaba plug. Now, I'm not sure if that'll actually even work because I don't have one of the servos to try it, but essentially the servo would need a connector, a special connector, in order to work as a regular servo. And oddly, because it's a direct power servo, it's going to need a connector or a special battery with a connector in order to run off the battery. So there are some batteries for crawlers that will have a power lead off of that servo can plug directly into. So you won't actually need any other connectors or anything. It's just that one servo can plug into the battery directly if you're getting one of the Lipo batteries that does have a direct power servo lead on it already. The only problem with that is that it will only work for a single servo, because that setup is essentially designed for steering servos. Most trucks have one steering servo, and so the batteries that are to go with those servos usually only have the one power lead that comes off of them. When in our situation, we're really going to be running dual hop servos, and when running a dual hop servo, you're going to need, of course, 2 power leads. And none of the batteries actually come set up with 2 power leads. All of the ones that I've seen, at least, only have the 1 power lead. So in order to run a dual servo setup on the hop, you would need to have a connector in order to basically jump the power from the battery to the servos. Piston pumps, you do need to buy that connector in order to bridge into the battery connection between the battery and ESC. And essentially, we can already do that just by using the connector. A different connector, of course, but another connector at the battery point could be used to supply voltage to 2 servos without having to have a servo that's specifically designed to take direct voltage. A simple connector that I'm going to show you how to use is going to solve that problem and basically turn any servo into a direct power servo. And one of the real downsides to the direct power servo style setup is that when you have a servo that's made to be direct power only, you can't actually just run it like a regular servo. You need to have another special different connector in order for it to plug into the receiver just like a regular servo. So there's no way to actually really run the servo without a special connector. Let's get into it. So what you'll basically see is I got the RC Hop Shop connector right there. It's got my 2 power leads. Those go off into some extensions, which then plug into my RX Eliminator connector. This is basically how I make this setup plug and play. You don't need to run this type of setup exactly. I'll get into that, but this is essentially how I have mine set up. So with that, I'll pull this out the car and we'll see what's up. So with that, I'll pull it out the car and lay it out. Alright, so this is essentially what it boils down to. This is the RC Hop Shop dual servo connector with quick disconnect. This is actually a quick disconnect you can set up with a long wire to have it hang out the trunk. And pop that to disconnect the battery. So we're not really going to focus on that. What we're more focusing on is these 2 power leads that come off the connector. So essentially, one side plugs into the ESC, the other side plugs into the battery, and it's basically just jumping that connection and taking the 2 power leads for our servos directly off the connector. And essentially it's the same thing as the connector that you would need to use to run the piston pumps. So the piston pumps will basically run off a connector like this, only it'll have 2 of them. The RC Hop Shop uses the regular servo plugs instead. But essentially it is the same thing. So what a lot of the guys are doing is they're basically taking the servo wire itself and they're pulling out the signal wire and basically attaching it, crimping on its own plug. So with these RC connectors, you can actually get the pins and the connectors, and you just crimp yourself on another connector. So what a lot of the serious dedicated hop guys are doing is they're actually pulling off that signal wire and crimping on its own connection. So that would have one connector for the signal wire going into the receiver, and then a second wire that would plug into the connector for the direct power to the servo. Essentially, that would create the same connector style as a piston pump. Same thing, would have the same drawback. So you have to, use a different connector in order to then use it again as a regular servo. It wouldn't work just directly plugging it in. So myself, what I use instead, so that I'm not actually forcing myself to use connectors to run the servo regular, in case I want to use it as something else, or change the setup, or run off a back, or any other reason, is I use what's called an RX eliminator. Now essentially what this does is it takes the one connector from the servo, plug that in correctly, and it splits it into two for us. So it basically is the exact same thing, just using a connector. So instead of having the servo come forcing you in order to run, a connector to run it normally, or forcing you to run a direct power setup using one for signal, one for power, the RX eliminator is a plug and play connector that does the exact same thing for us. So for me, I use this one here, which will take our power. This one plugs into the receiver, and because it is a female to female, what I do is I use a male extension. Simple as that. This one plugs in here. This one plugs in here. And boom. Now I have my setup. This gives me the freedom to have this at the back towards the battery, and then this swings around into the front, plugs into the servos. This then goes into the receiver, and right there we have a direct power setup for any servo. But essentially, this wire trickery is how you run any servo direct power. So I mean, it's not a huge crazy setup to do. You do need to make sure that all your connectors are connected correctly. Black on black, red on red. If you're running like the crazy guys that go all out, they simply pull out the signal wire and crimp on its own connector, essentially creating a piston pump style servo. Or like myself, it's either called, it has two names, it's called an RX eliminator or an RX bypass connector. Same thing, I get them at Homes, Hobbies, and with this you can essentially just run any servo you want direct power with a 3S battery. That's going to be 12.6 volts. So I mean, that's a lot of juice on these servos that are really designed to run a maximum of 8.4 volts. There are 9 volt circuitry, so there's that little 0.6 volt of safety window, but we're really going way past that safety window, running them at 150%. So yeah, when it comes down to it, this is essentially the setup. You can get one of these connectors at the RC Hop Shop. When it comes to the rest of the electronics, it's going to be a standard setup with no external BEC. We're going to be running the power off the regular ESC to power the rear servo, steering servo, and receiver. So the wire that comes off the ESC has to have red, white, and the red, black, and white going into the receiver in order to give that the power. So if you're running a BEC before that had the external, you had that red wire removed, you have to make sure that's put back in order for you to be able to give power to the rest of the servo. So it's basically a standard setup as if there is no external BEC running the power off the ESC itself. Alright, so I'm doing this little quick test so you can really see the difference we got going on here. So So we have this servo here on the right. This is going to be direct powered through the RC hop connector. And then we have the other servo just directly plugged into the BEC. So this servo is at 8.4 volts, and this one here is at 12.2 is what I got on the battery. So you see the difference here. Now I'm using these slow factory red servos just because they're slow enough. I don't have to actually go into slow motion to show you a difference. So you can just see how much faster the servo on the right is versus the servo on the left. Pretty substantial, and it's essentially what we're doing here. We're boosting the performance by putting more voltage to the servos, and they're going to be faster, stronger. All right. So what you'll basically see is I got the RC Hop Shop connector right there. It's got my 2 power leads. Those go off into some extensions, which then plug into my RX Eliminator connector. This is basically how I make this setup plug and play. And this is what it's all about. So we got dual pump servo pumps in the front, running on direct power, 12.6 volts. We got the rest of the setup is on the internal deck of the ESC. So that's going to be at 8.4 volts because it's a Hobby Wing G2. And yeah, so let's go ahead and plug it up. And in the back, I've got A81 BHPs. So essentially, we've got original piston pumps in the rear and super pumps in the front. Now this is a high lift build, so my target for this one was a really high lift in the back and being able to still hit bumper without turning into a kickstand. Notice that is a jacked up back end. So, and I don't run any of the subframe spacers, so I do need to flip that switch a little bit to get that hop going. So yeah, that's basically it. I'll also show you a video clip of my Monty hopper banging on 12 volts. Let you see that. And yeah, basically when it comes down to it, that's what we're running, and you're really going to be surprised with just how cold or cool the hop servos are. I mean, none of the electronics are getting hot in this scenario. Essentially, the reason, like my theory behind that is that because we're at such a higher voltage, the servos are going to be pulling less amps in order to activate the servo, and the lower amps due to higher voltage is gonna keep the heat down. It seems like it. These are, I bang with these servos at least 5-6 minutes hop sessions, and they don't get hot at all. So I'm not really too worried about the setup. So far, everything seems to be working, fine and as it's supposed to. I will, if I do run into some issues or some unknown problems, or find something to add into the system to make it a little more safe or whatnot, I will definitely update on that. But for the moment, this is basically it right here, man. This is essentially a 12 volt direct power hop servos and 8.4 volts on the rest, all running off a 3S battery. No back. No, there is a back. There's still the internal back, but there's no external back. Yeah, that's basically it in a nutshell. So with that, I hope the video answered a lot of questions, helped some people out who want to try this. I will say that my suggestion is that this setup is not really needed for most people needs. Running with a BEC, running a 3S battery and an external BEC, and then using the BEC to direct power the servos to around 9 volts is really the kind of target where you want to be for most regular RC guys that just have a street hopper or whatnot. That's the safe range where nothing's going to break, everything's going to work properly, you're still going to have great performance. This is more like a competition style build. If you're going to be trying to hit those hop comps, or one of these crazy high lift type setups, this is way more lift than you normally have in the rear of these 64s. So unless you're doing a crazy build that's needs that performance, best to run it 9 volts with a BEC. That way you got steady, consistent power from the beginning of the session to the end. One of the problems with running these servos direct power is they get most power when the batteries are fully charged. So as you're hopping and as you're going through the session, they're literally getting weaker pretty much on every hop, because the power that you're getting is going to be from the voltage. And essentially what's going to happen is you're going to be pulling less and less voltage, more and more amps. So if the scenarios, as the battery is getting less and less voltage, it's the danger of too much amps heating up the servos and causing a problem is going up and up and up. As it is full pack, I basically run it till around 11.5, 11.6. So I'm basically killing out 1 volt. With that, the servos stay nice and cool. There's no problem. I think any lower than that, you're going to start pulling a lot more amps on the servos, and that's where we can start running into problems with the servos burning out and whatnot when your battery pack starts getting a little too low. Alright, so that's going to be it for the setup on direct powering hop servos. If you got any questions, throw them down in the comments. I'll do my best to answer them. With that, I'll catch you in the next one.